story begins in the early 20th century. A young Austrian woman who was passionate about physics would try to make her mark in a world that was not ready for her. Born in 1894 in Vienna, Marietta had an early passion for science and mathematics. She earned a PhD at just 24 years old. Her main achievements were in her groundbreaking work with nuclear emulsions to detect cosmic rays and high-energy particles. In the early 20th century, scientists diving into the newly uncovered world of nuclear physics faced a major challenge. They had limited tools to explore the inner workings of atoms. Imagine a speeding proton zipping through space. You can't actually see the particle itself, but you can see the evidence of its path, the trail it leaves behind, like the vapor trail of a jet flying high in the sky. The mass, speed, and charge of the particle affect the tiny grains in the special nuclear emulsion film, leaving different kinds of tracks depending on the particle's characteristics. At the Radium Institute, where she worked, Marietta worked on improving the unreliable film that were being used. One of her biggest focuses was cosmic rays. This had become a huge scientific interest at the time. Since cosmic rays get scattered and weakened as they pass through Earth's atmosphere, researchers needed to get their equipment as high as possible to catch them in their purest form. Back in the 1930s, that meant using high-altitude balloons. So, Marietta and her assistant travelled to the mountains in Austria to set up emulsion plates around 7,500 feet above sea level. When they recovered and developed the plates, they found what they expected, lots of cosmic ray tracks, mostly protons, but unexpectedly, some of the tracks they found didn't follow the usual straight or curved lines with clear beginnings and ends. Instead, they ended in strange star-like patterns, almost as if tiny fireworks had gone off inside the film. Marietta was intrigued by these unusual patterns, and she wrote a letter to the journal Nature calling them disintegration stars, or Erdtrümmerungssterne in German. This discovery sent shockwaves through the physics community, as Marietta and her nuclear emulsions not only confirmed a theory but also paved the way for decades of future discoveries in particle physics. But, unluckily for Marietta, her scientific career was interrupted due to the rise of fascism. Marietta was Jewish, and for years she had struggled to find funding for her work or secure a permanent academic position due to anti-Semitism. Several of Marietta's colleagues at the Radium Institute were Nazis who stole credit for her work and tried to have her removed. When the Nazis took over, Marietta had to flee her home altogether. And her former colleagues stole her ideas as she had left behind some of her scientific notebooks and data. Marietta found herself in Mexico, where with a little help from Albert Einstein she obtained a teaching position, but still the lack of financial and scientific resources made it difficult for her to continue with her groundbreaking research. To support herself and her mother, she took on teaching undergraduate physics and doing basic industrial work instead. Meanwhile, her former colleagues back home thrived in their careers as they continued to build on Marietta's pioneering work. Nominated for but never awarded a Nobel Prize, in fact she lost to C.F. Powell, a man who had discovered the pion with the help of Marietta's method. Health and energy steadily declined as she struggled to make ends meet, and she passed away from cancer and heart disease in 1970. Marietta was not given an obituary in any scientific publication at the time. Her vision contributed to our understanding of the very fabric of the universe. I do tell the story of Marietta Blau.